All right. So it looks like we were over here. Suppose you want to form 3-digit numbers using a set of digits 0, 1, 2, 3, 4, 5. For example, 501 and 224 are such numbers, but 035 is not. How many numbers are possible?
Like, does it mean that 0.35 is not the
Right.
anything?
So how would we figure out how many numbers are possible given this type of setup here? You could do that, but there's an easier way. But it's related to that anyway. How are we gonna start counting it though? What would you do? Is it working, the charger? Say it one more time. Um, 1, 2, 4 could be fine. I mean, they just want to know how many 3-digit numbers are there that we can make out of these numbers. Pretty much what you were saying is really more or less all we really need to start thinking about. There's a little bit more, but not much. Can't you think about it based off of like the digits of the number? What does the first digit have to be?
Non-zero.
So what can we do with that? Well, we gotta talk about how many ways we can do something. So how are we gonna use that to say how many ways we can do the whole thing? You do 2, 1, 4. But if we, how many, what about what we said to talk about, like in terms of the counting stuff? We said we should make something with respect to the slots. Is that right? So how many slots do we need?
3.
3 is correct. And then what? That's correct. Good. There's 5 choices for the first one, right? Then what? 6. And then what about the third one? 6. If that's all I have to tell you to be able to do it, and then you can end up doing it yourself. Because I mean, literally, I asked a few questions, but then honestly, when I was asking the questions, you didn't answer them. But then all I said was make the slots. That's correct. And if you couldn't reuse numbers, the second one would have to be 5, right? That's correct. But that's a good question also. It's just, it doesn't necessarily, thank you. So a volunteer note taker is needed for this class. The note taker may use supplied carbonless paper or allow the student to take a picture of your notes with their smartphone. Volunteer note taking will not require you to do any extra work. All you're being asked to do is share your notes in some form with another student. Accessibility resources will provide you with a letter recognizing your volunteer hours. If you're interested in volunteering, please see me at the end of class. Does anybody mind contributing their notes? You don't mind? Thank you. Thank you. Either that or just take a picture and then email it or whatever. Thank you. Yeah, but she's just gonna do it on her thing, and then she's probably just gonna send you that. Yes, then I'll email it to you. That'll be easier. All right, so 180, but you see what I'm saying though? Like this question, I think is pretty confusing. But then once you start saying to yourself, oh, there's 3 digits, and then I have to start saying how many ways there are for each one. It's not really that bad. Is that correct? All right, but you gotta remember to use the slots. Does that understand? All right, what's the probability that a randomly selected number is a multiple of 10? All right. Oh, we're gonna do that one. So now they're saying probability. They just said how many numbers are possible here. Now he's saying probability. Does that make sense? So they're saying the probability that the number is a multiple of 10. All right. Well, we know probability is like some sort of fraction. What do I have to write on the top and what do I have to write on the bottom? The total is on the bottom, is correct. What'd you say? The number of the things that are multiples of 10 is correct. So then this is the number that are multiples of 10 divided by the number that's total. Well, we already did the total. Is that correct? What's that? 180. I'm just gonna write it as 5 times 6 times 6 though. All right. What about the multiples of 10? How are we gonna do that? You could do that, but there's a little problem though, because we don't have all of the numbers. But you could do it that way. That would work. It's not that hard, honestly, to do it that way, but there's a much easier way. Using the same type of idea that we just did from the last one. Or, wait, that's correct. Final number must be a 0. So what then? The final slot would be 1 is correct. Does that make sense? Does that make sense? If you're divisible by 10, that means that the final digit must be a 0. Is that right? So this last slot right here has to really be a one. Does that make sense? Now, another thing that we could do is we could actually just think about this another way. So I could say the same thing where it's a probability that it's a multiple of 10. And then what we could do is we could just start thinking about it directly in terms of the slots. Because we could say, what does the first thing have to be and the second thing and the third thing? Does that make sense? The first one really could be any of the 5 numbers. Is that right? The second one could be any of the 6 numbers that we could choose for that digit. Does that make sense? And then the third number, really, there's only one choice. Now it's almost the exact same thing. It's just that I'm thinking about it in parts instead of all together. Does that make sense? All right, so then the answer would just be, well, this cancels, this cancels, this cancels. We got 1/6. Does that make sense? Because the only thing that has to be true is that the last number has to be a 0. So there's a 1 out of 6 chance that that'll happen. Is that right?
What percentage is that?
16.66666666, whatever. Does that make sense? What is the probability that a randomly selected number is a multiple of 6? 5. Reading is important. Times 2 the amount of times is correct. So the answer is going to be 1/3. How can we calculate it though? Again, try and think about your slots here. What's the probability for the first slot? What has to be true for the first slot?
one of the following.
5 out of 5 choices. Is that right? What's the second one? 6, because we have 6 choices for this one,
Oh, good.
right? What about the third one? 2 out of what? 6 is correct. Does that make sense? So then we end up getting 1/3. Does that make sense? What is the probability that a randomly selected number is not a multiple of 5? That's correct. That's correct. So the probability it's not a multiple of 5 is 1 minus the probability that it is a multiple of 5. So that's 1 minus 1/3, or we get 2/3. Question with this? Question? All right. Conditional probability in events involving and. Conditional probability is the probability that an event happens, knowing given that something else has happened. The probability of event B is commuted on the assumption that the event A has occurred. This is called the conditional probability, is denoted P of B given A. So this line right here, we said a long time ago at the beginning of the class, like when you write that line, it means given. So this just means if I write this statement here, P of B, this means the probability that B occurs given A has already occurred. So the probability of B given A, so I like to think about it like this, that we say that there's a reduced sample space. So if I say given A, if I say given A, well then really that part this portion over here, we don't really have to worry about it anymore. Because it's said in there, given A. So given A, this is the only place where A occurs. So if A, that's the only reason where A occurs, then if I say probability of B given A, now it really now means the chances that this part happens, because that's the only place where B occurs. So if I say, what's the probability of B given A, another way we can say this is, it's the number of things in A and B divided by the number of things in the entire sample space, which the sample space now we're going to consider as just A. If I take both of these things and I divide by the total, on the top and the bottom of the fraction, then what we could say is that the probability of B given A is equal to the probability of B and A divided by the probability of A. Or you could just say count the number of things in all of A and then count the number of things in here and divide. Does that make sense? It'll make a little more sense when we do some more questions, but I think this should make sense. Question?
I guess what's the purpose of it?
So like, if I say to you, what's the chances that you have a black card in the deck, right? It's 1/2, right? 50%. So the chances that you get a black card in the deck is 1/2. Is that right? What's the chances that you get a black card given the fact it was a 4? Well, it'd still be 1/2. Is that correct? Does that make sense? There's four fours.
Yeah.
Right? 2 of them are black. Is that correct? So this really didn't change here. Does that make sense? Because of this fraction stuff, really. But like this one and this one are black. Is that correct? Right? So you could say that there's 13 plus 13 out of 52. Is that right? Or you could say, in this case here, if they're 4s, right? It's just 1 plus 1 out of 4. Is that right? But it's the same thing. Does that make sense? Because it turns out that these two things are independent from each other. The proportion of black things inside the group 4 and the proportion of black things overall is the same. Does that make sense?
Yeah.
All right. But sometimes that's not true. Like if I say to you, what's the chances that you're a black card? Okay, we know it's 1/2. What's the chances you're a black card given the fact that you had a club? What would the answer be then? 100% is correct, because all the clubs are already black. Is that right? What's the probability that you're a red card given the fact that you're a club? 0 is correct. Out of the clubs, the chances you're going to be red is 0. Is that right? So how are you doing this in your head so easily? Because what you're doing really is you're saying to yourself that we have this entire sample space. Right? But when I'm asking the question club here, right? You're reducing it to just this part. And that's what I mean by the reduced sample space. Does that make sense? You understand what I'm saying? Because if I say, given the fact that something is occurring, well, why do we have to worry about, like, if I say to you, what's the chances that, given you're a girl, what's the chances you're going to pass the class? Well, I don't care what the boys are doing then. Does that make sense? Like, it doesn't matter. It's like, Take them out of the equation. Does that make sense? Right? So that's what I'm trying to say with this thing here. It's like, oh, we have this whole thing we have to deal with, but now we're really not having to deal with that anymore. Does that make sense? All right. I don't know if that answers your question, but that's. All right, from the sample space, S is equal to 1 through 15. A single member is to be selected at random. Given the event A, that the selected number is even, and this event C, that the number is prime, find the following. All right, let's just first identify what is prime here. Does anybody remember what I mean by prime? So is that a no? I just want to know what does prime number mean again? No. A little more than that, but it's very closely related to what you're saying. So prime means, what are you gonna say? Prime means that any number that cannot be divided by anything evenly except for itself, okay? A prime number means a number which is divisible, or an integer, I guess I should say. Which is divisible by 1 and itself. Therefore, 2 is the first prime number. So in other words, like 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, etc. Does that make sense? Does that make sense? Question? They said out of the first 15, what's the chances that we get what? C given A? Prime given even? They want to know what's the probability that it's a prime number given it's even, I believe. Just confirm that's what it says. C given A, yeah. Oh, before we go from here, this part, are the following equal? And then why or why not? If I say the probability of A given B and the probability of B given A, are those two things the exact same thing or not? Why? Go ahead, what were you saying?
Well, I just finished the homework that I was due like tomorrow. I think it's tomorrow and day after. I did that myself. But yeah, I did all the work, all the homework in previous classes. I need to do it. Yeah, I can't go back. Do what I was.
Yeah, but it's closed now though. I opened it up until last week. All right, but what, are these two things equal or not? Why or why not?
Things happening. if they're saying, what's the probability if A is happening, if B is happening, right?
What's the probability A happens given B happens? What's the
Yeah,
probability B
right.
happens given A happens?
So in both situations, they will happen. Because,
Yeah, that's, they do both happen, but
they will happen. Both systems.
but does that mean they're gonna happen at the same rate? So why are you saying yes? Or why are you saying no, excuse me? Do it the same way we just did it in terms of the picture. So what would it be if this is, if the chances that B given A is this region divided by that region? What would the other one be? So they're different. Oh, you are saying they're different. Well, if someone asks you something like this, right? Either this has to be true all the time, or there has to be one time where all you have to do is come up with the fact that it's not true. Is that correct? Does that make sense? So if we don't think it's true, all we have to do is come up with one time where it's not true. So. I want to think of an example. I want you to give me an example where it would not be true. So tell me two things, A and B, where the probability of these two things are not necessarily going to be equal to each other. Was it-
So
Go ahead.
one like fishing, given that they have fishing rod, it doesn't necessarily.
No, that's true.
So you're saying, what's the probability that you're going to be fishing, given the fact that you have a fishing rod? And what's the probability that you're going to have a fishing rod, given the fact that you're fishing? Okay, I mean, I don't honestly expect these two things to be equal to each other, but I guess so. All right. It's
What's the problem? What's
I,
the-
but I would say you're probably correct. It's just the thing is we can't really calculate these. So
I wanted to say, if I was fishing, what's the probability of me getting fish, what's my fish on? Or versus me not getting fish,
not the same question. Not the same thing in this case. Were you saying something? That should work. I think I mean, this is not wrong what you're saying here. It's just hard to say how it's 100% correct. But but I agree that those would not necessarily be the same thing. All right. So that would really sort of count. But what about what he just said? So let's say we have the numbers like 1 to up till 10 or something. I don't know, let's call that A. All right. And then let's say E is for even. All right. So what's the probability that we have an even number given the fact that we're an A? Well, it would be, I guess, 5 out of 10, or we get 1/2, right? Right? But then what's the probability that we are A given we are even? What's the answer to that? Mm, what's the chances we get something from in here out of all of the even numbers? Well, it'll be like 10 over, I guess, infinity. It'd be like 0. Does that make sense? There's way too many even numbers to sit there and start picking just those. Does that make sense? The chances you get just those is gonna be really small. Is that right? You understand? You guys get it? But anyway, the point is these two numbers are not the same thing. Does that make sense? What's another example that they always use? Oh, the one they always say is like, what's the probability that it's dark given it's midnight?
Yeah, it's one, that's,
And what's the probability it's midnight given it's dark? So this one is more or less 0. This one in Florida is more or less 100%. Does that make sense?
Yeah.
Given it's at midnight, it's dark outside. Is that correct?
Yeah.
Right? So given it's midnight, what's the chances it's dark? About 100%. Given it's dark, what's the chances it's exactly midnight? Almost 0. Does that make sense? It's exactly is almost, there's way too many other times that are possible. Question? Understand? So A given B and B given A is not necessarily the same thing. But if you just think about it in terms of the picture, I think it's pretty simple, honestly. So like if we just draw this like, so let's say A is here and let's say B is there. So let's say this is A and let's say that's B going across and going up. Does that make sense? All right. So then what's the chances that what's the chances that you're B given A? Well, that would be the chances in this part that you're in here, right? This thing is, what's the chances that you're A given B? That's the chances out of this thing you're in there. Not the same thing. Does that make sense? Does that make sense? Total is different. So like if A is this part here and B is this part here, then in the first case, if I say B given A, then really I don't care about this thing. I just say, oh, sorry. I don't care about this thing. I just say what's B out of that part. Does that make sense? Here, if it's A given B, then it needs to be the chances that the A stuff happens given B. So that's really that part out of the blue part. It's not the same answer necessarily. Does that make sense? You get it or no? All right, so this is the same crap I just said, except you just wrote the formula. So the why is my pen not working? So if you have A there and B there, right? Then B given A is like your new total. And then where is B still happening? Only in here. So that's B and A. Does that make sense? Does that make sense? All right, from the sample space, whatever, C given A. So the chances that it's so A is it's even and then C is that it's prime. All right, so these again are the primes here. All right. So how would I do the first one? C given A. So you give an A, not add. Don't say and, you'll get it wrong if you do that.
No, I'm talking about.
Oh, you could do that, yes. C and A over this. But I was just doing it the way I was saying it before. You don't even need the formula.
Oh, okay.
So just think about whatever the total is. Think of out of that total, how many are you getting? Does that make sense?
I was during spring break, I was out of state. So I wasn't able to do it like, I'm always doing that. Yes,
Alright, so you give it A. 6 out of 15. Okay, 6 out of 15 would be the answer if the if we're talking about primes out of the total. But that's not what they're saying. They're saying, what's the chances that it's gonna be prime, given the fact that it was even, right? One out of 6? No, close, but no. How do you get 6? Oh, no, that's completely backwards. Because if I say, what's the chances that you get a prime given it's even? Is that what you're answering? What are you answering? Correct, okay? So you're doing it the other way, okay? You're just reading the question wrong. You're not thinking poorly, really. You're just not for this, you're not answering the right question. You're answering the next one, actually. Do you understand? No. Something about one, but so you're telling me it's 100%?
No.
One means 100%, right?
There's six primes. in the-
Okay,
Only one of them is even.
okay. Try and do it the way I was saying it from before. Always do the denominator first. What is the total? What's the total in this case? No, total is not, no. Where do you get 7? 7 evens is correct. There are 7 even numbers here. It says, what's the chances that this thing happens, given the fact that it was A? Well, it says given A is that they're even. So you should be asking about the even things first. Is that correct? So like this is even, 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 that's even, that's even. Is that right?
That's 11. That's a G next to, that's the 7 right next to them. That's a number or?
8, 7, 8, 9, 10, whatever.
Oh,
And this stuff here. So these are the evens. What's the chances now that you get this thing? 1 out of 7. Okay, that one shouldn't have been that hard. Does that make sense? All right, now wait a second. You made a mistake, but after I told you you made a mistake, you should have been able to say that. Does that make sense? Okay? All right, it's fine if you make an error, you're reading it wrong, because honestly, anybody's gonna read it wrong eventually. Just don't do that when you take your test. But the thing is the, once I tell you you're reversing it, you should be able to figure it out. Does that make sense? All right, you guys got it? All right, what about the next one? A given C now. What does this mean?
So what's the chance numbers even if, if it's,
1 out of 6 is
but
correct.
yes, that's the one that I was in.
Yes. All right, so now this time now we have the green things, and now this one's the only one that's both of them. Does that make sense? Now, we could do this using the formula also, but I don't think you should tell me you need a formula for this question. Does that make sense? All right, so probability of C given A. The way we could do this is we write C and A on the top, just the same way you said it before. Probability of A on the bottom, because again, A is the given part, so A is now the total. So now probability of A. So now you have to answer both these two questions. So it kind of adds like, makes two questions, whereas beforehand there was only really one question. All right, so that's why I like doing it the other way. If I can, just thinking about it with number and total here. Does that make sense? All right, but then C and A divided by probability of A. All right, so A means even. So what's the chances that the thing is even? Oh, well, that would be 7 out of 15. Note, it does not say given here. Does that make sense? All right, then C and A, intersection C and A. So that means the only time it's both C and A is that thing. That's 1 out of 15. Now, every time when you have something like this, if it says like A over C all over B over C, you could think of this as A over C divided by B over C, which is A over C times C over B. The C's would cancel and you get A over B. Another way to write this though, another way to say the same thing, which I think is a little easier, is to say, if you multiply this by C over C, because multiplying by C is just multiplying by 1. Does that make sense? Does that make sense? Then this C would cancel, this C would cancel. So we would just get A over B this way, all right? Let me just show you with numbers real quick. If I say like 1/2 plus 1/3 all over 1/4 plus 1/5, okay? We could say this is 3 times 2 is 6. Then this is, you need to put a 3 here and a 3 there, so you get 3. You need to put a 2 here and a 2 there, so you get 2. This same thing, multiply 5, 5, 4, 4. So this is 5 plus 4 over 20. Then this is 5 over 6 divided by 9 over 20. This is this, because you have to flip over the second one. Then we should be able to cancel some stuff here. 6 is what? 3, and this is 10. So I guess we get 50 over 27. Does that make sense? All right, that's, sorry? Cancel 2 here and here. 2 goes into both of them. Does that make sense? Then here's another way to do the same thing. Now, this is just using the idea of canceling, but it's just saying, all right, get rid of all these stupid denominators so that we don't have to deal with them. Does that make sense? All right. So I want to think of the smallest number that'll get rid of all the denominators. All right. So 2 times 3 is 6, right? 4 doesn't go into 6. So then if we just double it, 12, 4 goes into 12. Does that make sense? Then 5 doesn't go into 12. So 5 times 12 is 60. Does that make sense? Or if you wanted to, you could just multiply all of them together. That would work also. It's just slightly bigger. 6 times 20 is 120. It turns out 60 is the least common denominator. Does that make sense? All right, so then if you multiply this by 60 over 60, 60 times 1/2 is 30. 60 times 1/3 is 20. 60 times 1/4 is 15. 60 times 1/5 is 12. And then that's it. You get the answer. So anyway, what I'm saying here is that if you have A over C all over B over C, you can just multiply by C over C. C's cancel to get A over B. Does that make sense? Or another way to say it is that we don't really need to divide by the totals here. All we got to do is 1 over 7. Because these two totals will cancel anyway. Does that make sense? You understand? All right, given a family with 3 children, find the probability that the oldest 2 are boys given that the oldest is a boy? Could, but what would you say? Nope. Half is correct.
I was gonna say 1/3.
Why would it be half? What's a way you could say it's half? The oldest kid doesn't really affect what's gonna happen with the younger one. Is that right? Like if I say to you that the oldest kid is a boy, what's the other one gonna be? Doesn't have anything to do with the oldest one. Does that make sense? Still 50% chance. Is that correct? All right. So we would just get 1/2. These two vents are independent from each other. It's like it doesn't matter that the oldest one is a boy. Does that make sense? All right. Let two cards be dealt successfully without replacement from a standard 52 card deck. Find the probability that the black card is dealt second, given that a black card is dealt first.
Well, no, we don't.
Because they're saying that what in the question tells you whether you're gonna have to ignore it or not? What's the key word? Without replacement is correct. Does that make sense? Because they're not putting it back in for you to select it. Do you get what I mean?
Yeah.
So if it said with replacement, then we would have to put the thing back in each time, then it would be the same chances each time. Is that right? But it says without replacement, so the sample space is sort of changing. Is that correct? So it does matter, right?
26 out of 52.
26 out of 52 normally is correct.
Or could we subtract
So 25 out of what?
51?
Thank you. Because one of the cards is missing now. Is that right? Some card got dealt. Is that correct? Does that make sense? Any question here? Guys?
The word is completely not.
Excessively just means one after another. Did I write stuff here? I did. I did. Come on, man.
What is the closest between the person?
That I couldn't tell you.
No, no, I don't know. Because
Depends on what's wrong with it, honestly.
Oh,
2008, I wouldn't even bother fixing it.
I got it for $20.
It's too old. Oh, I definitely wouldn't fix it. I'd buy another one. So the 'cause you can buy an old one for pretty cheap, honestly.
I
But-
got it for $20 at thrift store. That's what I'm saying. It was only $27 to get a new battery.
That's not bad, but still, it's not gonna be worth it. All right, independent events or independence. Events A and B are independent if the following are true. The outcome or lack of outcome of A does not affect the chances that B occurs, nor does it affect the chances that B does not occur. The outcome or lack of outcome of B does not affect the chances that A occurs, nor does it affect the chances that A does not occur. In other words, they have like nothing to do with each other. Does that make sense? So it's like if he flips a coin over here and you roll a die over there, right? If he flips and gets heads, and then you roll your coin, you roll your die, and like, does it matter what he got? Makes no difference. Does that make sense?
Mhm.
They're independent of each other. Just like what we were talking about previously with the children, and the two oldest children were boys, or what's the chance the two oldest children were boys, given the fact that one of them was a boy, right? The oldest one was a boy. Well, the chances the other one's gonna be a boy is still 50%. It really makes no difference. Does that make sense? All right. So sometimes you have to worry about things being dependent or not. So first we start talking about whether they're independent. All right. Independent's easier. Does that make sense? All right. Dependent events. Events that are not independent are called dependent. There is some relationship between A and B then. So with replacement really means they're independent from each other because you're putting the thing back in to be selected. Nothing really changed anything. Without replacement really means they're dependent. Does that make sense? All right, so here's an example. So let's say I have these three marbles in a bag, green, blue, and red. I say without replacement. What's the chance I draw a red one on the first one? 1/3. What's the chance that I draw a red one on the second one? Well, given the fact that I drew a red one on the first one, without replacement, there would be no more red ball in here. So therefore it would be 0 out of 2. Does that make sense? So the probability changed. Is that correct? They're dependent. Is that right? With replacement though, if I sat here and I said, oh, you draw a red ball on the first one, then what's the chance I draw a red one on the second one, given the fact I drew a red one on the first one, but I'm replacing it, I'm putting the red ball back in here. It's still 1/3. Nothing changed here. Does that make sense? We say they're independent now. Does that make sense? Question?
Oh, remember that day I mean, it was on the class?
Yeah, but I can't do that.
You just had me.
I'm not allowed to. So two events are called independent events if the occurrence of one of them has no effect on the probability of the other one occurring. Oh, these things are a little annoying, the question sheet picks. But anyway, 2 planets are selected from a list of 8 planets without replacement. Are the events, the first one selected is closer than Earth, and the second is Neptune, independent events.
Huh?
Let's just say something first to say how we can check if things are independent, okay? So if A and B are independent, then the probability of A given B is really just going to be equal to the probability of A. Also, the probability of B given A would have to be equal to the probability of B. Because if I say A given B and they have nothing to do with each other, right? What's the chances something happens given the fact that he flipped the heads? Heads has nothing to do with it. Well, it's going to be the same chances that that original thing happens. Does that make sense? Does that make sense? All right.
Why did we 50%?
For the heads, yes. But I'm saying what's the chances that the rocket takes off tomorrow, given the fact that you flip the heads? Same thing, the chances the rocket takes off tomorrow no matter what. Does that make sense? The flipping the coin really has nothing to do with it. In that case. All right. So then but Well, I guess that's really it. All right. If they're independent, then those two things have to be true. Does that make sense? All right. But then we also have this result also. So using the previous formula, probability of B given A, we said was equal to the probability of B and A divided by the probability of A. Is that correct? If A and B are independent, then we know that the probability of B given A is really just the probability of B. Is that right? But then that must equal to the probability of B and A all over the probability of A. Does that make sense? Then what I can do is multiply this to the other side. So then we would end up getting the probability of A times the probability of B must equal to the probability of, well, let's write it this way, I apologize. Probability of B times the probability of A must equal to the probability of B and A. So this is the next formula they want you to know. If A and B are independent, then probability of A and B is equal to probability of A times probability of B. In general, probability of A and B is equal to, we could think about it with our slots. First, if I could say like, I want A to happen, then I want B to happen, given A happens. Or we can say we want B to happen first, and then A to occur, given B has occurred. Does that make sense? Either it's these two formulas, or if they're independent, this thing just becomes just B. Does that make sense? This one would just become just A. Questions, sorry? This is the and formula. They just call it, this is when you start doing questions that involve and. Right? But let's see if we can do this question here. 2 planets are selected from the list of 8 planets without replacement. Are the events, all right, so what are these stupid planets? I don't even know what the stupid planets are. Mercury, Venus, Earth, Mars, right? Jupiter, Saturn, Neptune, Uranus, right? Or is Uranus Neptune? I have no idea. I don't remember. No, I think you're right. Pluto is for some reason not considered a planet anymore. It's based off of like when it orbits and stuff like that, if it can maintain the orbit and stuff. So that one's like too far away and too small. So that's why. So like if they start calling that a planet, they have to call the rest of this stuff rocks, planets. Honestly, a bunch of these other things are just rocks too, but yeah. Well, like if you have a comet, right? Okay, so like there are comets, like you've heard of like Halley's Comet and stuff like that before, right? So like these comets, they'll come through. So like you have this thing that's orbiting this other thing, right? And then like this comet will come flying through, which is really just ice. Most of the time, that's all the comets are. Comes flying through, and then it goes around and gets affected by the gravity, and then it gets pulled back. And then every so once in a while, it gets sucked back in, and then it gets slung shot right back out, right? I mean, it's really orbiting also. You know what I mean? But it doesn't have a stable orbit. So that's why. Does that make sense? There's all these rocks that are between like, I think it's Mars and Jupiter. Like they call it the asteroid belt or something like that, right? Those things are orbiting also. But they're not stable. Because if there wasn't all the rest of those rocks nearby, they would just go flying all over the place. Because they would get sucked into some planet. All right, anyway, whatever. All right. Are the events the first selected is closer than Earth? Okay. And the second selected is closer, the second selected is Neptune. All right. So they want to know if these two events are independent. Does that make sense? So let's try and do it based off of what we said previously with the definition thing before. Let's call this one A and let's call this one B. Let's try and calculate the probability of A given B, the probability of B given A, and the probability of A and the probability of B. If they're independent from each other, this would have to equal to this, and this would have to equal to this. Does that make sense? Does that make sense? All right, so A given B, what were the chances that, what's the chances that is true? No, it's, you gotta be careful what they're saying here. Sorry, maybe I read it wrong originally. It says, because I just read it the same way you just said it, now I realize that's not what they're asking. So with replacement, it says, are the events, the first selected is closer than Earth, and the second selected is Neptune. Does that make sense? So this is kind of a confusing question. So let me help with the first one. How about that? Okay. So it says the first selected is closer than Earth, right? That means it has to be one of these two, Mars or Venus. Is that correct? One of those is gone. I don't know which one. They picked one of those. Does that make sense? Does that make sense? Oh, wait, I'm sorry. I read it backwards. B, let's look at B first. So B says the second selected is Neptune. Great. The second time they're picking Neptune. Does that make sense? All right. We want to calculate A given B. Does that make sense? So we're assuming that B occurred. That means the second one is being selected is Neptune. Is that correct? Right? But if B occurred and then we want A to happen, right? First. Does that make sense? What's the chances A happens first and then B happens, given that B happens second? Not 100%. So let's try with the formula first, and then we'll go and see if we can reason it out the other way. So the formula is A and B all over B, right? What's the chances B happens first? Or what's the chances B happens? The second selected is Neptune. Now, this is not that simple, okay? The probability that the second selected is Neptune, or let's just call it B because I called it B before. The chances the second thing is Neptune, we can either think of that as, if we're going to get Neptune, it could either happen given the fact the first one selected was not Neptune, or the first one selected was Neptune. Those are the two cases we have to break it up into. Does that make sense? So first I'm going to do the probability that the second selected is Neptune, given the fact that the first one is Neptune, times the chances that the first one is Neptune. Well, let's write it this way, I'm sorry. The probability that the second selected is Neptune and the first one is Neptune. Or the probability that the second one is Neptune and the first one is not Neptune. So this is the probability that B and this plus the probability of this and this because they're disjoint. Either you're going to get Neptune on the second one, given the fact the first one was Neptune, or you're going to get Neptune on the second one, given that the fact the first one wasn't Neptune. You're not going to be able to actually get Neptune on the first one or the second one if the first one was Neptune. Is that right? All right. So first, I'm going to say the probability of Neptune on the first one times the probability that it's B, given the fact that you had Neptune on the first one. Then I'm going to say the probability that it's Neptune on the second one times the probability that it's sorry, I meant to write this. All right, the chances that it's Neptune on the second one, given the fact it's Neptune on the first one. Neptune on the first one can happen, but if Neptune on the first one happens, we can't get Neptune on the second one. Is that right? So it's 0. The chances that we don't get Neptune on the first one is what? No. 7 out of 8. There's 8 of them. The chance that we don't get Neptune is 7 out of 8, right? What's the chances now that we end up getting Neptune on the second one? So I don't know what we picked the first time. We picked one of these first 7 things here, right? One of them's gone. What's the chance we get Neptune on the second one now? 1 out of 7. So in other words, it's 1 out of 8 is the answer that we get Neptune. So that was an easy way just to think about it. We could have just said 1 out of 8. Does that make sense? Right? What's the chance you get Neptune? All right. So now, what's the chances that you get A and B? In other words, the first is selected is closer than Earth. The second selected is Neptune. So closer than Earth is what? 2 out of 8. Is that correct? What's the chances that it's B? The second one is Neptune. Now, we picked one of these again, though, for the first one. So let's say we pick this one, right? So then it's 1 out of 7. Is that right? So then these 8s cancel. We get 2 out of 7. All right. Now, if that's the exact same thing as just getting A, then we're fine. A is the first selected is closer than Earth, but we just said A is 1/4. So they're not equal to each other. Does that make sense? Does that make sense? So they're not independent or they're dependent. Does that make sense? For the experiment, determine whether the 2 given events are independent. The answers are all guessed on a 20-question multiple choice test. The events are, the second answer is correct and the third answer is correct. Are they independent? You could. But you would have to do the second is correct, given the fact that third is correct. And then you would have to compare that to the second is correct. And then you would also have to do third is correct, given the second is correct. And you'd have to compare that to just getting the third correct. But there's a key thing here that makes it easy. Because the answer is definitely that they're independent. Why? Because I'm guessing on all of them. It's not like if I get the third one right, then I know what I'm doing. Does that make sense? Is that right? If you got the third one right, does that change whether you get the second one right? You just guessed. So if you want to do this thing here with the formula, which I don't really suggest. Well, actually, we can do it, but it's just kind of not very helpful. So if you get the second and third corrections correct, they didn't even tell us how many questions there are, how many choices there are. So let's just say there's 5. I'm just gonna make it up. So the chance I get the second one right would be 1/5. The chance I get the third one right would be 1/5. Chance I get the third one right would be 1/5. These just cancel. Is that right? And then it would be 1/5, 1/5, 1/5 again. They just cancel. Does that make sense? You understand? Question? All right, multiplication rule. So this one I already said here. If you have A and B, you say A, then you say B given A. Does that make sense? It's like A is the first slot and then B is the second slot. Chips are placed in a bag and drawn at random 1 by 1 without replacement. If there are 3 blue, 5 white, 1 yellow, and 7 red, what's the probability the first 2 chips are white? Tell me.
Do you know the total budget? So 16, right?
Out of 16. That's correct. So very good. So then this, so the thing is like, we need to think about it with the slots, okay? So the first one has to be the chances that we get a white one on the first one. The second one needs to be a chances that we get a white one on the second one, given the fact we got a white one on the first one. Is that right? What's the chances there's gonna be a white one on the first one? This one should be easy. It's 5 out of 16. Is that right? Then the thing is one of those white ones is gone. So then it's gonna have to be, there's only 4 remaining out of the 15. Does that make sense? Now, Akamuri, just when you do this, so like here, 4 cancels with 16 because 4 goes into both of them. So this is 4 and that's 1. Does that make sense? 5 goes into both of these. So this is 1 and this is 3. So we get 1 times 1 is 1, 4 times 3 is 12. Does that make sense? No, you don't have to, but it's a lot easier. All right. Otherwise, you have to use a calculator. But the thing is I'm just saying, like, people who are forced to use a calculator all the time on these things will not realize when they're getting it wrong, and you will make a mistake typing it in. Now, I would still do it on my calculator to check it. Does that make sense? Question with this? What's the probability of drawing a red and then a white? So red on the first one and then a white on the second one now, I guess. Nope. That's correct. See, how could it be the same thing? You gotta draw a red one, right?
Oh, 'cause it's 7 red. Come on.
All right, now what? Then what? 5 out of 15 is correct. Now, again, just saying, like, if we do this with the canceling, 5 cancels with this thing right here, you get 1, 3. Does that make sense? Because 5 goes into both of them, right? Divide top by 5, divide bottom 5. All right, so then you get 7, 16 times 3 is 48. Does that make sense? If the chips are drawn with replacement, what's the probability both chips are red? Not for both of them. No, you got, it's 7 out of 16, and then it's 7 out of 16. But the thing is, you have to multiply it out.
Oh, okay.
So then this is 49 out of 256. Or just do it on the calculator. Does that make sense? Those are not going to cancel because 7 doesn't go into 16. Well, there's no common factors. Whatever. Does that make sense? What's the probability of drawing a red and then a white? And now he says with replacement, though. Good. So that's 35 out of 256 now. Does that make sense? 7 times 5 is 35, right? Any question? Should be all right. But you see, like, this stuff takes practice. Like at the beginning of class, if I asked you the same question, I'm telling you, you would have been like, I have no idea how to do this. All right. And I guarantee, like, in a couple of days, you'll tell me, well, I don't remember. You know what I mean? But that it doesn't take that long to be able to do it also. Like if you just do a little bit of practice. Does that make sense? All right. So a pet store has 11 puppies, including 5 poodles, 2 terriers, and 4 retrievers. If Rebecca and Aaron, in that order, each select 1 puppy at random without replacement, find the probability that both select a poodle. Okay, I have no idea why we need to know about Rebecca and Aaron, but all they're really asking is what's the chance that we select 2 poodles? Does that make sense? Or over what? No, 21.
Oh,
Because it's without.
21.
Okay. So what's the probability that we get poodle on the first one and poodle on the second one? So that's the probability that we get poodle on the first one times the probability that we get poodle on the second one, given the fact that we got poodle on the first one. Poodle on the first one, that's 5 out of, what is this, 11, 16, 6 is 22. Then poodle on the second one is, there's already 1 poodle been selected, so there's only 4 remaining out of 21. Does that make sense? So then 4 goes into this 11, so that's 2. So then we get 10 over 11 times 21. What's that? 210 plus 21, 231. Does that make sense? Question?
Because of 20 people.
16 plus 6. Oh, yeah, because I'm blind. I added 11 twice. Sorry. You're correct. Should be 5 out of 11 times 4 out of 10.
That's what I was thinking.
No, that would be dumb. So this is 2. Sorry, we get 2 out of 11. Thank you. Sorry.
Me too.
Nope, I can't read.
This one was
Yep, except for the fundamental part. All right. Question with this?
real quick. That's my.
It's funny how people always tell me they can read
I love when
until you get a math problem. Nobody can read it. So the let 2 cards be dealt from a standard 52 card deck without replacement. What's the probability that 2 aces are drawn? It's not that bad. The 4 out of 52 is the same thing as 1 out of 13, right?
Yeah. No, but it would be
3 out of 50.
one.
I made the same mistake twice. 3 out of 51. Does that make sense? 3 out of 51 is the same thing as 1 out of 17. So this is 1 over 13 times 17. I don't know what that is. So that's 170 plus 51. So that's 221. Question? What's probably the first card is an ace and the second card is a jack. You get what I'm saying though with the slots, right? 2 slots, right? 1 out of 13. Four out of 51. Does that make sense? 4 out of 51 times 13 is 510 plus 153. So that's 663.
Do you have similar?
It's already, you can't go in there.
Doing one.
Does that make sense? Because the top part's even. Whereas to only 2s goes to the top thing. The bottom one is odd. Question? Well, I'm saying the probability of this event happening. The first slot's now representing the probability that you get this thing. Second slot's representing the probability that we get a jack, given the fact we got that thing the first time. Does that make sense? 4 families each have 2 sons and no daughters. Assuming boy and girl babies are equally likely, what's the probability of this event? 4 families each have 2 sons and no daughters. Okay. So effectively, it's just saying that you get 8 babies and they're all boys. Does that make sense? Does that make sense? So it's just 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 8 times. Because that means you need to get a boy on the first one, and a boy on the second one, and a boy on the third one, and a boy on the fourth one, and a boy on the 8th baby. So then it's like we got 1, 2, 3, 4, 5, 6, 7, 8 slots, and they all have to be boys, given the fact the previous ones are boys. But the next one being a boy has it's not dependent on the last one being a boy. Does that make sense? So in other words, it's just 1/2 times 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 1/2, and hopefully I made 8 of these. So we get 1 over 2 to the 8th is 256. Does that make sense? From the sample space S is 1 through 15, a single number is to be selected at random. Given the event A, that the selected number is even, and the event C, that the selected number is prime probability of A and C. So I kind of actually like what she's doing here with this question. Because, so first of all, she says this.
Yeah, I thought that.
But I kind of like what she's doing here because what she's trying to say is that it gets confusing to say sometimes, if I say to you, what's the chances? Now, if I say it in English right now, you're not really going to get confused. Okay. But if we start doing the question, people start mixing or conflating these things a little bit. All right. So if I say to you, what's the chances that the person who passes the class is a girl or the person in the class is going to pass and they're a girl. Does that make sense? That's really out of everybody. Because I said and. Does that make sense? Now, if I say to you, what's the chances that you pass if you were a girl? That's really given. That's really saying out of the girls, what's the chances that those people are going to pass? That means we're ignoring the boys completely. Does that make sense? Whereas the first time I was saying, what's the chances that the person is a person who passes and is a girl? That's out of everybody. Does that make sense? You get what I mean by that? Let me just try and make it with a table a little bit, just 1 second. So let's say we make this thing called two-way table. So you could either be a boy, or in this thing we're claiming, you could either be a boy or a girl, according to the question. And then you could either, let's say, pass or not pass. Right? Now, if I say to you, what's the probability that you're a girl and you pass? Let's say there's like, this is 1, 2, 3, 4. Let's say the total, or n is equal to 1 plus 2 plus 3 plus 4, right? The chances you're a girl and you pass is 2 over n. Does that make sense? Does that make sense? What's the chances that you're passing given the fact you're a girl, though? That is, given the fact you're a girl is just this part. So and given, they're not the same. Does that understand what I'm saying? Given, you've changed the entire sample space. And you mean out of the whole thing. Does that make sense? So she's giving this question here because she's trying to show you that people make a mistake on this crap all the time, and we want to make sure that we know which one's which. Does that make sense? So from the sample spaces, blah, 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 is a single number to be selected at random, given the event A, that the selected number is even, and the event C, that the selected number is prime. Find the probability of A and C. Note this is different from the previous examples. So there's two ways you can do this. We can start using the stupid formulas, or you can do it by just thinking about what it means. I'm gonna do it both ways, all right? But you should always try and do the thinking way first, because a lot of times you can just answer the question. Like I could just do this one in my head and I just know the answer immediately. The answer is 1 out of 15. Why is it 1 out of 15? These things are not actually independent.
Oh, wait, because there's only one prime number that's even.
That's correct.
So
So it's just 1 out of 15 because I could just say number over total. Is that right? Isn't 2 the only one?
Yeah.
Right, we wrote them all out before. Is that correct? 2 was the only one that was prime, which is also even, because every other even number, 2 goes into them, so they can't count. Does that make sense? Does that make sense? 2 has only factors 1 and 2, right, itself. So therefore it's prime, right? Okay, so that's one way to do it. Does that make sense? Other way to do it is start using the formulas. So A and C is the same thing as A times C given A. Or we could do it with C and A. We could make C happen first, and then A given C occurs. All right, what do they want now? A single number is to be selected at random. All right, so the single number is to be selected at random. So A means even. Chance that we select something even is 7 out of 15. Is that right? Now, what's the chances that it's a prime given that it's even? Well, that's 1 out of 7. Is that correct? Does that make sense? C means prime now. What's the chances it was prime? I think we said there was 6 primes before. So it's 6 out of 15. Is that right? Do you remember what I'm talking about? 2, 3, 5, 7, 11, 13, 6. Does that make sense? sleeping again. I'm just kidding. So then A given C. So now given C, so there's 6 of these. What's the chances it would be even? Because now given it's a prime, what's the chance it would be even? 1 out of those. So we get 1 out of 15 here. We get 1 out of 15 there. We don't really have to do this twice or 3 times. I just solved it 3 times. Does that make sense? Any of those would have been fine. All right. Any question? But I think it helps with this stuff to see it from like the different angles a little bit. Does that make sense? Because, and then this is what I meant before with all this fraction stuff. It's just hard to get what they mean otherwise. Does that make sense what I'm saying? All right. Now, I just want to say also how I can say right from the beginning why this is independent or why this is not independent real quick. Does that make sense? All right, so let's try and make that little table that I was making before. So we have, let's put evens here. So then this would be odds, right? Primes. And then non-primes. Does that make sense? Right? All right, odds we know 1, 3, 5, 7, 9, 11, 13, 15, right? Every prime is going to go in there except for the 2. Is that correct? So that's 3, 5, 7, 11, and 13. 2 goes over here. Is that correct? Non-primes that are even is what? 4, 6, 8, 10, 12, 14. Odds that are not prime is 1 and 9 and 15. Does that make sense? I think that should be all of them. Let's make sure I put all of them here. So this is 6, or it's 5 plus 1 is 6. This is 3 is 6 is 9. So we have 15 total. So this looks good. Does that make sense? All right, I might as well just add up all these subtotals anyway. So then this one is 3 and there's 5 here. So there's 8. So there's 7 over here. Okay, any question? All right. So obviously you have 1 here, 5 there, 6 here, and 3 there. Okay. All right. Now, I was talking about this like independent dependent thing from before, right? So you remember that whole thing we were talking about with the black cards before, right? And I said, what's the probability it's black overall? And then what's the probability it's black given it was a 4, right? It was 50% each time. Is that correct? Because they didn't affect each other whatsoever. Like the chances of the black thing inside of this place where there are 4s is the same as the chances overall. Sort of like just like zooms in. Does that make sense? Right? So then, and that's because also another way we can think about it is we could say that like there was 26 is to 52 as 2 is to 4. Is that correct? Right? All right, so here, what's the chances that it's even? Well, evens are what? There's 7 out of 15, right? What's the chances it's prime? There's 6 out of 15, right? Right? What's the chances that it's prime given it was an even? 1 out of 7. What's the chances that it was even given it was a prime? 1 out of 6. Is that correct? Does that make sense? If we want to say that it's going to be independent, this has to be true. That means that the probability that it's even in prime, which is definitely 1 out of 15, is that right? It's supposed to equal to the chances that it's even, which is 7 out of 15, times the chances that it's a prime, which is 6 out of 15. That's not correct at all. Because this is 42 out of 225. That's not right. Does that make sense? Does that make sense? So like, why is that? So if we're saying the two things are independent, it's like when you kind of zoom in and just take that smaller set, that the same proportion keeps happening. Does that make sense? So if we're odd, doesn't that change whether or not we're going to be prime or not? How often primes are happening? Primes happen way more often when they're odd. Is that correct? There's only one even prime. Is that right? Does that make sense? So it's not like sitting here and saying like fours and the whole deck, right? It's like saying, what's the chances you're black given you're a club? Well, 100%. Is that correct? You understand what I'm saying? They depend on each other. If you're clubs, you're black more often. If you're black, you're clubs more often than normally. Does that make sense? They affect each other. Is that correct? You know what I'm saying? Right? So like you have to ask yourself, if it's a prime, is it more likely that it's going to be even? Is it even? Is it more likely it's going to be a prime? Right? If it ever changes or gets easier or harder or anything like that, then automatically they're dependent. Does that make sense? Any question here? I think we went through that a lot. All right, I guess let's just stop there because otherwise we're going to finish this class way too early. So I guess we'll carry on next week. All right. That I have no idea. It should be a while. That's why I don't want to keep going. You get what I'm saying? I could finish everything and I could just tell you guys, hey, we don't have any class anymore and stuff like that. But I don't really want to do that. You know, I mean, I can finish everything in like 3 weeks for the whole class if I really wanted to. But no, I would say that's not good. What's the maximum? I can do the first chapter in one day. I can do the second chapter in one day. Third chapter, I can do that in one day. Fourth chapter, one day. Fifth chapter, one day. Sixth chapter, one day. So it should take about 6 weeks, month and a half for the whole class. Maybe you guys started late?
Wait, no. So this is 60, yeah.
No, this is I think the full session one.
Yeah,
So like this, yeah, I think there's a full session class. Full session is 18 weeks actually.
18? No. No.
That was 18.
I was this. Nobody.
I never remember.
I don't even.
Maybe it's 18 including the holidays. Maybe that's what I'm thinking of. You know what I'm saying? Because like the first week and last week are kind of shorter or something like that. And then there's always a holiday because either it's Thanksgiving or it's spring break. I can't remember. Something is 18 weeks. I know that. When I do it with blended, I do it in either an hour and 15 minutes or an hour and 2 hours and 30 minutes. But I don't find that's good. I find it's better to go a little slower. Yeah, I don't. Yeah, you could do a lot of things. It's just that I don't know if it's the best way to do it. You know what I'm saying? You wanted me to check the test, is that right?
Yeah. The next one is due the 9th. 9th of April.
We'll probably finish the whole class by then.
Wait, seriously?
Yeah, we only have like 2 more things to go over. The next chapter is easier.
Well, we still have stuff that's due up until.
Yeah, I figure it's better for me to go over it and then you guys have your, yeah, you know what I mean? Because then you could ask a question and stuff like that, but
Will you still be available